Welcome to The Explainer. Today, we are diving into a really powerful teaching strategy. And this one isn't just about memorizing facts. It's about building a deep, lasting understanding of an idea.
So let's kick things off with a question that I think is at the heart of all real learning. How do you teach an idea so it actually sticks? Not just enough to pass a test, but so it becomes a genuine part of how you think.
Well, a big part of the answer lies in something called concept attainment. Now, this is an inductive teaching model that came out of some really groundbreaking research by a psychologist named Jerome Bruner. And inductive is just a fancy way of saying that instead of just giving students the answer, you turn them into detectives. They have to figure out the concept for themselves by looking at clues.
And as Bruner pointed out, this whole process of sorting things into categories, well, it's not just for the classroom. It's actually a fundamental way our brains cope with the world. Think about it. We're constantly bombarded with information, and categorizing helps us make sense of it all.
All right, so here's what we're going to cover. We'll look at what concept attainment is, how to prepare a lesson, walk through the actual inquiry cycle, talk about defining the concept, how to adapt it, and finally, why this whole thing even matters. Let's get into it.
Okay, first up, preparing the lesson. The funny thing is, the real magic of this model actually happens before anyone even steps into the classroom. It all comes down to two crucial prep steps.
So the first thing a teacher has to do is pick one single concept and define what are called its essential attributes. Basically, these are the non-negotiable rules for being part of the concept club. To make this super clear, we're going to use a simple, classic example for this explainer, the concept of a rectangle.
Right, so for rectangle, here are the essential attributes, the absolute must-haves. 1. It has to be a four-sided figure. 2. It has to have 4 right angles. And 3. Its opposite sides have to be parallel and equal in length. If a shape is missing even one of those things, it's not a rectangle. End of story.
Okay, now for step 2, developing the examples. This is where it gets really interesting. The teacher creates 2 lists. The yes list contains positive examples that follow all the rules. And notice how a perfect square is a yes because it totally fits our definition. But the no list, the negative examples, is just as crucial, maybe even more so. These are the tricky ones, the close but no cigar shapes. A rhombus, for instance, it has 4 sides, but if it doesn't have right angles, it's a no. And it's this contrast, this comparison between the yes and the no, that really helps students figure things out.
All right, the prep work is done. Let's head into the classroom now and see this thing in action. This is the inquiry cycle, and it's really the heart of the whole model. This is where the students get to do the detective work.
So the teacher starts presenting the examples, maybe one at a time or in pairs. But here's the key. They don't say what the concept is. They just say, this one is a yes and this one is a no. The whole point is to create a little mystery and get the students to start looking for patterns, just like detectives searching for clues.
And with every new example that pops up, the students are constantly comparing. They're looking at the yes pile and the no pile, and they start making guesses or hypotheses about what the secret rule could be. This is the engine of the model right here. Present an example, compare it, make a guess, and then refine that guess with the next piece of evidence. So, as the students throw out their ideas, the teacher writes them down for everyone to see. Someone might say, "Oh, I got it. It's things with 4 sides." And that's when the teacher strategically pulls out a rhombus and puts it in the no column. Ooh, okay, so it can't just be that. Then another student guesses, "It's things with right angles." So the teacher shows an L shape and says, "Nope." See what's happening? By strategically using those negative examples, the teacher helps the students eliminate bad hypotheses and slowly zero in on the right answer.
So after a few rounds of this, the students are getting really close. They've gone from wild guesses to having a pretty solid idea of the rules. Now, it's time to make it official and define the concept.
This is the moment where the class puts it all together. They come up with a name for the concept, rectangle. And then, and this is so important, they work together to write their own definition based on the attributes they discovered. It's not some definition from a textbook that they're memorizing. They built it themselves. They own it.
And this quote just nails it. The whole point of this model is to stop just telling learners what to think. Instead, it lets them actually participate in building their own understanding. It completely flips the script from passive listening to active construction.
But we're not quite done yet. To really solidify things, the teacher might throw out a few more new, unlabeled examples and have the students test out their brand new definition.
And then, for the final step, the teacher can ask them to think about their thinking. When did you have that aha moment? What clue made it all click? This is amazing because it's not just teaching them about rectangles, it's teaching them about how they learn. Now, here's one of the coolest things about this model. It's not some rigid do-it-this-way-or-else formula. It is incredibly flexible, and you can adapt it to all kinds of learners and situations. So you can totally change how you present the examples. You could dump them all out on the table at once and say, okay, sort these. Or if you really want to up the challenge, give them all the examples completely unlabeled and have them figure out the groups and the concept from scratch. It becomes this awesome tool for reviewing ideas or even for assessment.
And this flexibility is what makes it so great for meeting individual needs. For learners who might be struggling a bit, you stick to simpler, more concrete concepts and give them a bit more structure. But for your advanced learners, man, you can throw some really complex, abstract concepts at them. Think about trying to define something like justice or irony this way. You can challenge them to develop their own examples, making sure every single person in the room is being challenged right where they are.
Okay, so let's get to the bottom line. Why does this model matter? What are the lasting benefits? Why should anyone who teaches, or frankly, anyone who just wants to learn better, care about this idea?
Well, the benefits go way beyond just learning one specific concept. Think of it like a workout for your brain. This model builds some serious mental muscles. It develops powerful inductive reasoning skills, which is the foundation for science and problem solving. It also teaches you to be okay with not knowing the answer right away, to have a tolerance for ambiguity. And maybe most importantly, it makes students active participants in their own learning. They're not just passengers anymore, they're in the driver's seat.
So really, it all comes down to this. The process forces you to think not just about what something is, but also what it isn't. And that creates a much deeper, more solid understanding. So think about this in your own life. The next time you're trying to wrap your head around a complex idea, at work, in a hobby, whatever, try this out. Ask yourself, what are the perfect examples of this idea? And just as important, what are the things that are close but are definitely not it?
Thanks so much for joining me for this explainer. If you want to dive deeper, all the key sources we used to put this together are listed right here for you.